Hello everyone. I am Professor Vishal Evlikar from Department of Mechanical Engineering, PES Modern College of Engineering. So in this lecture series, I am going to teach you Dynamics of Machinery, which is your 7th semester subject. So before starting this subject, we must have some basic idea about the mechanism, how the dynamics of machinery is classified, what exactly the meaning of word dynamics. Okay, so we already studied the concept of mechanism in theory of machine. So so mechanisms are basically classified into two types: statics and dynamics. Basically, static deals with the objects at rest, whereas dynamics is nothing but the study of objects which are in motion. Okay, so see, these dynamics is again classified into two types: kinetics and kinematics. Kinetics is nothing but the study of objects which are in motion, considering the cause of that motion. That is what we call it as a force. Okay, and in case of kinematics, study of objects in motion without considering the cause. So we don't have to consider the force here in case of kinematics. Okay, now see, this subject dynamics of machinery is broadly divided into two parts, or we can say it consists of two major topics. So first one is balancing and second one is vibration. So firstly, as per your syllabus is concerned, first three topics are based on your vibration. Fourth chapter is of balancing, and fifth chapter is of how to control the vibrations. We have studied the basics of vibration in 3 units, and in right from fifth unit, we are going to discuss about the how to control these vibrations, and last unit is about the noise measurement and its control. Okay, so we are going to start with vibration. Now first question arises here is, what do you mean by vibration, or what exactly vibration is? Basically, vibration is nothing but, in its simple language, it is an oscillatory motion. Basically, oscillatory motion of the bodies in response to a disturbance is called as vibrations. So I have written standard definition of vibration here also: the motion which repeat itself after equal interval of time. So this is called as vibrations. See, basically, vibration problem occurs where there are rotating or moving parts in a machinery particularly. And basic cause of vibration is due to presence of restoring force in the system. So this is most important concept. Presence of restoring force is the main cause of generation of vibration in the system. Okay, now this apart from machine itself, surrounding structure also subjected to vibration. Basically, study of vibration is necessary to understand their effects on mechanical systems, and this study has two major aspects. So first aspect is study, we are studying the vibration to reduce the amount of vibration generated in the system, and second aspect is study for industrial applications. Okay, so according to first aspect, vibration in machine components leads to cyclic stresses, isn't it? Due to continuous vibration in the system, cyclic stresses are produced, and these cyclic stresses causes failure as well as loss of energy in the system. Hence, vibrations are necessary to reduce. And for reduction of vibration, we first know what exactly the vibration is. Now, how vibrations are going to reduce? They are reduced by providing mountings, isolations, and there are various techniques. We are going to discuss in detail about these techniques. So this is the first aspect to study the vibration. And as far as second aspect is concerned, there are some applications where vibrations are necessary in the industry. Like we have seen the vibratory feeders, hoppers, or most of the time conveyors. So these are the industrial applications where we need to produce the vibration. Okay. Now next question arises, what are the various causes of vibrations? See, first and most important cause is vibrations are produced only because of unbalanced forces in the system. Whenever there is unbalanced forces in the system, there is a vibration. Second cause is elastic nature. Because of elastic nature of the elements in the vibratory system, the vibrations are elements in the particular mechanical system, vibrations are generated. Third one is external excitation. what we commonly call it as a forced vibration. External excitation means we are providing uh, drive to the system, or we are providing some prime mover to the system, and thereby we are providing external excitation in order to give the power to the system. So in that case also vibrations are produced, and natural calamities like wind, earthquakes, this is also one of the cause of generation of vibration in the system. Okay, so this is all about introductory level. After this, we are going to discuss the most important part of our syllabus. This is the that is nothing but the elements of vibratory system. So when we discuss about the elements of vibratory system, so we have to consider one simple spring mass system. So I have drawn here simple spring mass system. If you observe, you will come to know in this diagram, simple spring mass system is shown having mass m, which is attached to the spring of stiffness k. Okay, and this is nothing but the mean position. So I'm discussing about the first diagram. Simple spring mass system, spring having stiffness k and mass of magnitude m is there. Okay, so this is the mean position. Now consider the mass m is released after giving initial deflection x in this rectilinear direction or linear direction simply. When we provide external deflection, when we release this mass by giving an initial displacement of magnitude x, what will happen? Due to the spring, a restoring force, amount of restoring force is what? Kx. Okay, that restoring force try to pull this mass in upward direction, isn't it? And thereby causes the mass is going to deflect about its mean position. What will happen? There is a certain acceleration to this mass because of this deflection, and when it reaches to its mean position, so this is the mean position. So this line I have drawn for indication of mean position. So this because of this deflection, acceleration is provided to the mass, and when it reaches to the mean position, it has a finite velocity. It is having some velocity, hence the mass will not stop at the mean position. Okay, so mass is continuously vibrating about its mean position. Similar situation will be there when the mass again crosses the mean position, and now when the next position is what? Upward deflection. In third step I have shown here. In after what will happen after certain time, the mass crosses the mean position, and this sequence would keep on repeating. Means mass will uh, initially mass will be at this mean position. After giving initial deflection, mass will be at the second position, that is known as mean deflection, and this in third step there is upward deflection. So if you observe this mass location of the mass, it will moves in the upward direction, and this will be the new position, and this will happen continuously. And as we said, the definition of vibration, the motion which repeat itself after equal interval of time about its mean position, so that motion is known as vibratory motion. So here I can say that the spring and mass, these are the two elements of vibratory system. Okay, now after this we are going to discuss about the most important concept in the vibration, that is what we called it as a natural frequency. So natural frequency is nothing but the frequency with which mass vibrates in the absence of any external excitation force. Means when we provide initial displacement to the mass vibrates in the absence of external force. There is no external excitation force, just we are giving initial displacement, and hence this is called as natural frequency. And this frequency, the frequency possessed by that body after giving initial displacement without external force, that frequency is known as natural frequency. And this system, here we have discussed about this system. So this system is called as undamped pre vibrating system. So this is undamped pre vibrating system. So why I'm saying it is undamped? Because there is a only two elements. if you observe in these three diagrams, so this is basically single diagram. I'm tried to show you the different positions of the same diagram. So spring mass system, there is a no damper, hence we called it as an undamped free vibratory system. Okay, now but if you see practically, so in actual practice body comes to rest after certain period, body will come to rest, and this is because of concept of damping. To reduce the amplitude of vibration, we are using the damper in the system. Damper is nothing but the device which provides resistance to the system, which absorbs energy, and this system becomes now spring mass damper system. So if you observe this diagram, you will come to know this is your spring and mass system. Initially in its first position we have seen spring mass system. When we incorporated damper, so it becomes spring mass damper system. Okay, so this is what these are three elements of vibratory system. Spring, mass, and damper are called as basic elements of vibrating system. Okay. Now we are going to discuss more about the concept of damping, types of damper in detail in our next session. But up to this, we can say that these are the three elements of vibratory system which are most important, which we have to consider while solving the numericals of this category. Now, after this, we are going to discuss some of the important terms of vibrations. Like when we see, commonly we call it as a terminology in case of vibrations, or we can call it as a important terms in vibrations. So I'm going to discuss these terms one by one. So first term we are going to discuss is nothing but the periodic motion. Okay. So periodic motion is nothing but the motion which repeat itself after equal interval of time is called as periodic motion. Okay, second parameter is nothing but the time period. Time period. So time period is nothing but time required to complete one cycle is nothing but the time period, or we can call it as a time interval after which motion repeat itself is called as time period. For example, if I will draw here amplitude versus time plot. Okay, so let us say this will be complete cycle, isn't it? And this will be your time required to complete one cycle. For example, for this completion of this cycle, I will require 1 second. So I can say that this is time period of this particular cycle is 1 second. Okay, or we can call it as a time interval after which the motion repeat itself, started from this point, end at this point. Okay, and for next cycle it will repeat its cycle from this point, hence starting to end. So this time required to complete this complete cycle is known as time period. So generally standard formula for time period is nothing but a Tp equal to 2 pi upon omega in terms of seconds, where this omega is nothing but the angular velocity. Okay, so third term is nothing but the frequency. So as we all know, frequency is nothing but the number of cycles completed in 1 second. Number of cycles completed in 1 second is known as frequency. And as we all know, there is an inverse relation between frequency and time period. Frequency equal to 1 upon time period. Frequency equal to 1 upon time period. Therefore, formula for frequency becomes omega upon 2 pi, isn't it? And unit is nothing but hertz. Okay. So we are going to discuss more about this frequency. Then we already seen the term called as natural frequency. Okay, natural frequency is nothing but the frequency with which mass would vibrate in the absence of external excitation force. So this frequency is called as natural frequency, or we in general we can also say that frequency of free vibrations. Simple definition of natural frequency is nothing but frequency of free vibrations is called as natural frequency, and it is denoted by Fn, F suffix n, that is natural frequency. Okay. So next term is resonance. Okay, as we all know, in this system, if a body is vibrating, so it is having natural frequency, isn't it? And when we provide the external excitation force to that particular body, so the frequency of external excitation is another one frequency. So in this system there are two frequencies. Okay, so first one is natural frequency and second one is external excitation frequency. Now what will happen when the external excitation frequency is equal to natural frequency, or these two frequency will match, and what will happen, that condition is known as resonance condition. Okay, or what we can say, when external excitation frequency is equal to the natural frequency, resonance is said to occur. Means for resonance condition, natural frequency equal to external excitation frequency. Okay, that is the reason where if you see the complete syllabus, you will come to know most of the numericals are based on calculation of natural frequencies. Okay, so we are always interested to avoid this resonance condition. So what we do, we calculate the natural frequency. Once you will know the natural frequency, so we always try to avoid that value which is equal to the external excitation frequency, and thereby we can easily avoid the condition of resonance. Now what will happen at resonance means when these two natural frequency and external excitation frequency, when they will match, what will happen, there is a maximum amplitude in the system. And what will happen if the system is vibrating with maximum amplitude, there is a chances of failure of the system. Okay, hence we are always interested to avoid this resonance condition. At resonance, amplitude of vibration is too high, which leads to mechanical failure. Okay, so then after that we are going to discuss about the term degree of freedom, which might have you might have studied in theory of machine. Degree of freedom is nothing but the number of independent coordinates that are required to completely specify the configuration of a system, isn't it? So in in this particular subject, that is in dynamics of machinery, we are going to discuss about single degree of freedom system. Single degree of freedom system. This is called as SDOF, single degree of freedom system, and two degree of freedom system. But as far as your syllabus is concerned, single degree and two degree of freedom system is there, as well as one more system is also there, that is what we call as, if the degree of freedom is more than two, we call it as a multi degree of freedom system. But your scope we are going to discuss single degree of freedom system and two degree of freedom system only. Okay, so common example of single degree of freedom system is, so I'm going to draw one simple sketch here. Consider this is a simple spring mass system which we have seen. This is mass, this is speed. Okay, and if I will provide displacement to the system in this direction, mass supported on a spring and constrained to move in only one direction. Okay, if you observe this motion, you will come to know there is only one degree of freedom, and we can say it as a single degree of freedom system. Or one more common example is example of simple pendulum. So if this is the initial position of pendulum, and this will be the displaced position. This will be the displaced position. Okay, simple pendulum oscillating in one plane. Or one more common example is our slider crank mechanism. Okay, so these are the examples of single degree of freedom system. Okay, so in our next session we are going to discuss about the remaining important terms, that is two degree of freedom system, amplitude of vibration. Then we are going to discuss about the simple harmonic motion, what are the various types of vibratory systems, or vibratory motions. Okay, so I'm going to stop here. I hope it will be useful. This lecture will be definitely useful for us. So I will quickly revise what we have seen. Initially, we have discussed about some basic concept like mechanism, statics, dynamics, then dynamics classification of dynamics, kinetics, and kinematics. Then two major aspects of this subject, balancing and vibration. So we started the concept of vibration. We have seen the definition and concept of vibration. What are the various causes of vibration? Then we have seen the elements of vibratory system. Firstly, we have seen the spring and mass. Then in actual practice, we are going to use the damper in order to reduce the amplitude of vibration. And we have seen some important terms. Okay, we are going to continue these remaining terms in our next session. Thank you.